So for part D of this problem, we need to find the net torque on the wheel. Well, we know the torque can be two things. It could be I alpha, and it could be R cross F. So we just finished calculating some stuff about alpha. Maybe it's I alpha. From part A, we know alpha. If we could just calculate I, then we could calculate it using this equation here. So it says it's a solid cylindrical wheel. That means that the moment of inertia is 1/2 the mass times the radius squared. In the very beginning of the problem, they told us the mass and they told us the radius. So we can calculate this, and then we can use torque equals I alpha to calculate the torque. Then in part D, finally they ask us for the force. So we want force, and just after we finish calculating torque. Well, there are lots of ways to calculate force, but when you're thinking of force and torque, that makes you think of torque equals R cross F. And that means that the magnitude of the torque is equal to RF sine theta. We know the torque because we just calculate that in part D. And we know the R because it says along the edge of the wheel, so that's the same R that we used up here. It's the radius of the wheel that they gave you way in the beginning of the problem. F is what we're looking for, and it says that the force is going to be applied tangent to the wheel, so that means that theta is going to be 90, so the sine of theta is 1. So we're really just doing torque equals RF, so the force is going to be the torque divided by the radius.